wicking beds for, I don't know, probably 13 or 14 years now. And I've done a lot of permaculture, but five or so years ago, I decided I wanted to learn a bit more about the science of things, how things grow, and sort of work out what I was being told was just sort of pop culture or folklore and what really happened. So I went off to Charles Sturt Uni and did a Bachelor of Horticulture. And then following that, had the opportunity to do an honours degree and decided I'd like to do some research into wicking beds. One of the things I'd come to think after doing a bit of soil science and learning a bit about how water moved through soil was I didn't understand when you've got gravel with big spaces between the gravel, how water actually wicked up through that. And when most of the wicking bed designs are saying put gravel in the reservoir, I didn't understand how they were working. So I thought, let's go and do a little bit of research and try and answer that question for me and see what is the best way of doing at least the reservoir layer in a wicking bed. So that's what set me off on this journey. I now think I've got some understanding of what's happening inside wicking beds. I certainly don't know all the answers and don't know everything there is to know about constructing wicking beds, but it's at least a start and might prompt some discussion and might prompt some further research. So I'd be pretty sure that everybody that's listening today would know about wicking beds, but I thought it's worth just doing a quick overview of what is a wicking bed, just so that we're all on the same page. So wicking beds are a sealed growing container that's got a water reservoir in the bottom portion of it and a growing medium in the upper portion. And you fill the reservoir up through a fill tube, so you're generally not putting water onto the top of the wicking bed. You just put it in underneath, and then water wicks up by capillary action from the reservoir to the soil and into the plant's roots. And they generally have an overflow part of the way up so that the growing medium doesn't get saturated. The pictures down the right-hand side are just some of the wicking beds I've got here at the farm that I've been growing for quite a while. And I've used various different ways over the years of constructing those, and some things have worked and some things haven't worked real well, but there's not been a lot of method until I started these experiments, not a huge amount of method in doing things rigorously. Probably the biggest failure I've had in wicking beds was some of the early ones I did. I put a mixture of, I think I had gravel down in the base of them, but then used a mixture of just compost and potting mix above that. And that, where it was saturated, it really just broke down fairly quickly. And after a couple of years, what was down towards the reservoir layer, it just sort of turned to black sludge and wasn't really a very nice thing for growing plants in. So I've replaced that, and we might talk about some of the other things I've done instead. I started off looking at what had been published in the scientific literature. There's a huge amount on the internet, on blogs and on YouTube about wicking beds, but it's really hard to tell what's just people's opinions and how much they really know about what's going on there. So I turned to the peer-reviewed scientific literature, and I only found 3 papers that talked about wicking beds. And they found there were some advantages to wicking beds compared to just normal above ground beds, that they got better yields, they didn't need watering as often, they had better water use efficiency, so they used less water. But all the experiments that had been done had gravel in the reservoir and some sort of growing medium above. And they found that the depth of the gravel didn't make much difference, whether it was 150 or 300 millimetres deep. And the depth of the soil didn't make a lot of difference either. But that still didn't answer the questions I had about whether gravel was in fact the best thing to use. I also looked at literature for hydroponics, because Some of the hydroponics setups use what they call sub-irrigation, where they put water in at the bottom of the hydroponic pots and then water wicks up through the growing medium. So there was some useful information in there about what's used as growing media. But there's a few fundamental differences between the way hydroponics operates and the way wicking beds operate, as the hydroponics are generally done with what they call flood and drain, where they have a tray that the pots are sitting in, and they fill the tray up with water for a while, let it wick up into the soil in the pots, and then they drain the tray out, so then the pots get a chance to drain out and dry a bit. So they don't have a constant reservoir like wicking beds do. And as part of this, the growing media is often designed to drain fairly freely, and generally it's growing things in smaller pots and not terribly deep pots for the hydroponics. They also have the fertiliser, the nutrients are supplied in the water rather than in the growing media. Most people growing wicking beds will put compost in and put fertiliser into the growing media, just put plain water into the reservoir. Now, I don't know whether, what difference that makes yet compared to hydroponics, where the nutrients are in the water that wicks up from the bottom. But I think there are some useful things that we can learn from the research that's been done into hydroponics. So having seen what was out there and had been demonstrated already, I did a few experiments. The first one was just looking at how much water could various materials in the reservoir hold, with the thought that the more water they hold, the longer they'll go between having to water the wicking beds, which is one of the big advantages of wicking beds. How well does water rise up through the reservoir material so it can get into the soil? So that was just a couple of experiments I'll talk about more, just in isolation, not actually in wicking beds. And then I built some wicking beds with different materials in the reservoir. And I did two different sorts of wicking beds, some quite large ones and some smaller ones. And I'll talk about the results of what I found there. Ricky's just asked a question, do hydroponic or wicking beds tend to have better yields? I haven't seen any research that compares wicking beds with hydroponics. Hydroponics tends to be, certainly in a commercial setting, is managed very tightly about what moisture is in the growing medium and how much nutrients they're getting. And I think just because of that really close management, they're probably getting better yields from most hydroponic setups than from wicking beds. But they certainly require a lot more energy. They require a lot more management and a lot more maintenance than wicking beds do. But it's not something I've actually investigated in any detail. So my experiment with the water holding capacity was a pretty simple one. I had some takeaway food containers. I filled them with the various materials and then measured how much water I could add to the container before it was completely full. The things I tried were a cocopeat mix, which I was using as my growing medium, which was a mix of cocopeat, compost and sand. I used 10mm diameter crushed gravel, that was a crushed basalt, a blue metal, call it. Some crusher dust, which is the same rock, but it's crushed down quite fine. So it's got particles varying from very fine up to 2 or 3 millimeters. And it's typically used for providing solid beds under paving or bedding in pipes, things like that. The river gravel was, again, about 10 millimeters diameter, but they were rounded stones rather than the sharp ones, the crushed gravel. There were two different sorts of sand. One was called river sand and one was called washed sand at the local soil yard where I got them. I really don't have any information on what's the difference between them. The washed sand was probably had slightly more finer particles in than the river sand, but I didn't actually measure the particle size distribution in there. And then there was scoria that was sort of 10 to 15 millimetres diameter scoria, so it was reasonably small. It wasn't the biggest scoria you can get. So I filled those all up with water and measured them, and this graph shows how much water they could hold. So the cocopeat one held the most water, so I guess it was packed in fairly loosely, and that was one thing was a little hard to compare with how it would actually operate in a wicking bed, where it might tend to be compressed a little bit more, so it may hold a little bit less water if it was actually in a wicking bed. But the cocopeat mix absorbed water as well, so it wasn't just the spaces between the cocopeat particles that held water, it was actually inside the particles, so that was why it held the most water. The gravel did hold more water than the sand. The crushed gravel and the scoria were about the same, but there's not a huge difference, practically speaking, between the gravels and the sand. So, I mean, I thought if you had a reservoir full of gravel, it would have a lot more space in it for water than sand would, but the gravel was about 50% of water and the sand was 40%, which is a difference, but it's not a huge difference. The next thing I looked at was how well water wicked up through the various materials. Doing this, I had some clear perspex tubes that were 50 millimetres diameter, and I sat those in a container of water and then just measured every few hours how far up the column of material the water had gone. And you can see in that one, which would be cocopeat, you see where the colour changes, where it gets wet, and that would be sand, the colours up there, and that one's crusher dust. So that gave me a measure of how high the water could rise and an indication of how fast it would rise. What I didn't measure there, but I think would be interesting to do, is actually work out what is the volume of water that's rising up through the column. And that's probably something for further research. Before I go into the results of that, I thought it might be worth just talking a little bit about water and how capillary rise actually works, just so we've got a better understanding of why different materials might wick better than others. Water, I'm sure we all know, is H2O. It's I've drawn this wrong. It's two molecules of hydrogen and one molecule of oxygen. And I've obviously had a brain fade when I've drawn the diagram. Anyway, we can imagine it's labelled the other way around. But one of the interesting things about it is that it ends up being a molecule that's got a positive charge at one end of it and a negative charge at the other. And if you know from magnets, when you put two ends of magnets together, if they're opposite charge, they will stick together, and water molecules do the same. So they'll stick to each other, which we call cohesion, and they'll also stick to other things, to other surfaces, which we call adhesion. So if you've got water sitting in a container, a little bit of it will stick to the sides of the container and tend to rise up the sides a little bit, and that's where we get this meniscus on the little curve going up from the water at the next to the container. If the sides of the container are close enough together, as the water sticks to the side of the container and goes up a little bit, it will drag other water molecules up with it. And those water molecules will stick to other water molecules. And if the container is narrow enough, the whole water will rise all the way up the tube. Now, it's got to be a pretty narrow tube for that to happen. It's maybe a millimetre, maybe less. But it rises up the side until the forces of gravity are holding it down. So the smaller the tube, the higher up the sides it's going to rise. So what did I find in general, the fine materials had a greater rise. So the things with smaller particles packed in closer, and so the spaces between the particles, or in effect these capillary tubes, were smaller so that water could rise up them faster and further. So the crusher dust, which had the finest material in and had a good mix of sizes of material, so it packed in fairly well, that's this purple line here. So it rose very fast and rose quite a long way. So my tubes were only 500 millimetres tall. So that was as high as it would rise, as high as I could measure. But the crusher dust was still going up. The sand rose up fairly quickly, that's the red line, until it was about 300 millimetres up. And then it slowed down, but it was still rising. And this immediately puts to bed one of the things that I commonly hear about wicking beds is, and I used to repeat myself when I was running wicking bed courses because I'd read it so often, that water will only wick up 300, maximum of 300 millimetres. In fact, from the reading I did and what I've demonstrated, water, given the right sort of materials, will wick up a long way. And in fact, can wick up several metres. So it's really, if you're wanting to get water to wick up a long way, it's a matter of having the right materials, but it's certainly not limited to 300 millimetres. The cocopeat mix rose up to about 200 millimetres, but I did have troubles with that because starting off with it dry, it was, as a lot of compost and organic materials tend to get when they dry out, they get a coating on the surface that makes them hydrophobic and they won't absorb water or hang on to water until you get them really wet. So I think that the rise with the cocopeat was probably affected a bit by it being dry and taking a long time to re-wet. I tried starting off with damp cocopeat, but the problem was then I couldn't see any change in colour where the water had risen to. So there's another experimental technique there somewhat waiting to be developed that would let me actually see how fast the water rises in damp cocopeat. But the really striking thing of this is that the things with larger particles, the gravel and the scoria, didn't really wick very well. The 10 millimetre crushed gravel, it eventually got up to about 110, 115 millimetres. The smooth river gravel got hardly any rise at all. And the scoria also had very little rise. So that tells me that using scoria or river gravel isn't going to be terribly successful in the reservoir layer of a wicking bed. So the water would wick up from, if you have a reservoir full of scoria, water will wick up a little bit from the top of the scoria into the soil, but as soon as the water level drops a bit, it's going to stop wicking, is what I would guess. There's a question, so wicking limited by the size of your bed, wicking's better placed for smaller beds. If it depends on what material you've got. If you've got a nice fine material with very small pores, you could have a deeper bed. The beds I made were 500 millimetres in total, so they had about 200 millimetres of reservoir and 300 millimetres of soil. And I've been using beds like that for a long time, and the water seems to wick up to the top of the soil quite happily in those. And I'm not sure certainly for growing veggies, you don't really need them any deeper than that. But if you're growing trees in wicking beds, you may want to have deeper soil. But of course, the roots also go down to the bottom, so it doesn't matter so much what happens up the top of the soil once the plants are established. And I did use food colour when I did some experiments, which I haven't shown the results of here, looking at wicking in perlite, and food colour worked very well for that. Maybe I could find a dark enough colour that would make a difference in the cocopeat. So having done those experiments in the laboratory or in my workshop, in isolation of wicking beds, I then went out and built some wicking beds, built a polytunnel and put some wicking beds in it. And I'm not sure how many honours students start off by building their whole research facility, but that's what I did. So I did, the wicking beds I made in IBCs that I cut in half. And then I put a divider across the middle of each wicking bed, which is what these green things are. That's the top of the divider that goes all the way down to the bottom of the wicking bed. My hope had been that I'd be able to waterproof that join well enough that it would keep the two halves of the bed separate. But in the end, that the waterproofing wasn't 100% successful. So I ended up putting some pond liner inside the wicking beds. So if I was just using full IBCs, you wouldn't have to do that. But because I was trying to get more beds to experiment with, and I didn't have the funds or the space to do 16 full beds with IBCs, it was, an IBC is an intermediate bulk container. They're these plastic cubes with steel cages around them that are used to transport all sorts of chemicals all around the world. You can buy them secondhand because they're generally used just one time for their original purpose. You need to make sure you're getting one that's had some food grade product in it, because they also use them for selling glyphosate and all sorts of nasty chemicals come in them. But they're pretty freely available at rural stores and on Gumtree and places like that. So my construction was pretty much like the first diagram that I showed. The only real difference was, instead of having an overflow pipe that came out at the top of the reservoir, I put a hole for the overflow pipe in the bottom of the reservoir, and then put a clear plastic tube coming up to level with the top of the reservoir, so that the water would still overflow when it got to the top of the reservoir, but I'd be able to see how much water was in there. That worked really well for the beds that had a lot of free water in them, so gravel and the water ups products. But for the sand and the cocopeat I used in the reservoir, that tended to hold on to the water quite tightly. So imagine if you've got a bucket of sand you fill with water and then you drain all the water out of it. When no more water drips out of it, the sand is still quite wet. So the sand particles are actually holding on to the water. So what I was finding was that the level in my indicator tube would drop quite quickly as the free water in the reservoir was used up, but there would actually still be lots of water in the reservoir. So it wasn't a very good indicator for those beds. But where I had gravel beds or water ups in the reservoir layer, that gave me a really good indication of what the level of the water was. So what I used in the growing medium was this cocopeat mix that I based on some research that had been done in universities in America 40 or 50 years ago about soil mixes for growing in containers. And it was 6 parts of cocopeat, 1 part of compost that was just from our council, the urban green waste compost, and 1 part of washed sand. And so that was just by volume. So I just mixed those together in a concrete mixer and then put it into the beds. And I did add some fertiliser into that. I don't know, I didn't measure what nutrients were in the compost, but I wanted to make sure there were plenty of nutrients in there so that wasn't going to affect the growth of the plants. What I did down in the reservoir layer, I had 5 different things that I tried. The first was just having the cocopeat mix. So there was cocopeat mix in the reservoir and cocopeat mix up in the growing medium layer. And there was no geotextile between them. It was just 500 millimetres depth of the cocopeat mix all the way down. The second one I did was the crushed gravel. And for that, I did put a geotextile layer between the gravel and the cocopeat mix on top, so that the two didn't mix together. That's a pretty common design that's out there on the internet and on YouTube, all over the place. I did the same thing with sand. So I had sand in the reservoir, and then a layer of geotextile, and then the cocopeat mix on top. And the final treatment I did in the reservoir layer was a product called Water Ups that's been developed in Australia, made from recycled plastic, and the Water Ups people generously donated a box full of these to me so I could use them for my experiments. So they're basically it's like a plastic shelf with hollow legs, and you sit them in the reservoir of the wicking bed, fill up the legs with something that's going to wick the water up, and then put the soil on top. So you've got lots of free water around in the bottom of the reservoir, and a number of areas where water can wick up. So those are 400 millimetres square, and then the legs are about, I think from memory, about 75 millimetres square. Water Ups people suggested using perlite in as the wicking material, and I did that first, but I did some experiments with perlite after this was not working too well, and you really need to use a fine grade perlite with as smaller particles as possible, because I put in a medium grade, which was what the aquaponics shop sold me when I didn't really know anything about perlite, and turned out that didn't wick very well at all. So the first round of experiments I did with Water Ups, I don't think really gave a good result of what they could do. For the second round of experiments, I took out the perlite and put in sand instead, and as we'll see in a little bit, that worked much better. The fifth treatment I did, there was a question asked to me by my supervisors about how did I know that the cocopeat mix was going to be a good growing medium, and they suggested that maybe I should compare that with a commercial potting mix. So I did wash sand in the reservoir, the same as I'd done with the third treatment for the cocopeat mix, but I used this potting mix that I bought from Bunnings. So it wasn't the cheapest one around. I think it probably wasn't the most expensive one, but it certainly was a quite reasonable quality potting mix. So I had 5 different treatments with the 4 reservoirs and the 2 growing media, and I did 3 copies of each of those, so that I wasn't just getting a one-off result, and I could compare the 3 different results with the same treatment and see if they were really telling me the same story. And I allocated the position of those 15 beds randomly to the beds I had in the polytunnel, so that there wasn't any, if there was any effect from being near the end of the polytunnel or being on one side compared to on the other side, that I could use statistics to identify whether that was causing any problems and be able to deal with it. So the results I'm going to show are the averages of 3 treatments. Some of the beds with the same treatment did a little bit better, some of them did a little bit worse, but what I'm showing you is the averages. So to get the water into the bed, I had a bit of 50 millimetre diameter slotted ag pipe that I laid across the bottom of the bed. And then that was going into a PVC pipe that was my fill tube. Sorry. And then that's just a picture of the geotextile sitting on top of the gravel before I put the cocopeat mix on top. As it turned out, for where you've just got all sand in the wicking bed, just having one pipe down the middle made it quite slow to fill up the beds with water again. And just for making it easier to fill, it would have been better to have more water pipe, more slotted ag pipe in the bottom of the beds. The photo on the left is just the showing you the plastic tube I had up for the overflow and how you could see the water level in there. And in each bed, I put in a tensiometer, which measures the soil moisture. So as things were growing, as I was adding water to the beds, I measured how much water I was putting in. I measured what was happening with the soil moisture. Those tensiometers were linked to a little data logger that recorded the soil moisture every hour. I also used, I haven't got a picture of it, but a meter called a pulse meter that's made by a company in New Zealand that is just 2 probes, 2 steel spikes. You stick in into the growing medium, and it will give you the soil moisture as well as temperature and electrical conductivity. But it seems to be a fairly accurate tool. I think I had a look at the sort of cheap water moisture meters that you can buy from hardware stores, garden stores, and I'm not sure that they're particularly accurate. But this one was not very cheap, but it let me do measurements at various levels down through the soil profile, while the tensiometers were just sitting at one level, 150 millimetres down from the top. So I grew 2 different crops. The first one I did was I put spinach in all the beds, and that was just a photo from one of the beds of the progressive growth of the spinach. And then for the second round of experiments, I grew lettuce, little buttercrisp lettuces. And for both experiments, I had 12 plants in each bed. So the beds are about 1 metre by half a metre. So it was reasonably close spacing for the plants. There was a question from Kate, do the plant roots assist in wicking action? I'm not sure that they help with the wicking, but they certainly will go down and draw up water. So once the roots get down towards where the reservoir is, the wicking through the soil doesn't matter quite as much, because the roots will go down and get the water. But certainly, as the more shallow rooted crop and the younger the crop, the more important the wicking action is in the growing medium. So the results from my first experiment, where I was growing spinach, I dried the plants and weighed them at the end. Unfortunately, scientists seem to like comparing the dry weight of plants because it stops you sort of artificially pumping things up with water and getting heavier plants. If you do a dry weight, that allows you to combine the results from different trials at different times, where the plants may have absorbed different amounts of water. But it means I grow all these beautiful plants and then couldn't eat them. At the cocopeat and sand reservoirs did grow the heaviest plants, so it grew the most spinach. The sand and potting mix grew the least amount of spinach, and the gravel and water ups ones were sort of somewhere in between. So there's a fair difference there between the cocopeat sand and the gravel one. And also, I haven't shown you the graph, but I measured how much water was put into I used to refill the beds, and the more water I added, so that was the more water that was used by the plants, the heavier the plants were. So that's hardly surprising results, but I guess it's useful to know that there is that correlation. I did the same for the lettuces. They were looking quite fine lettuces. It was very hard to dry them. But across all the 15 beds, there was no significant difference in the weight of the lettuces. They all weighed about the same. I think the lettuce is a fairly fast growing crop. And I started off with the growing medium in the soil, in the wicking beds, completely saturated. So what I did was fill up the reservoir, water from on top of the top of the soil until the water came out of the overflow, so that they were all evenly saturated to start with. And I think there was probably just about enough water in the cocopeat mix to grow the lettuces, even without having to use any from the, well, not much from the reservoir. So it wasn't a particularly good test to identify differences, but I guess it did show that depending on what crop you're wanting to grow, it perhaps doesn't matter too much what you do down in the reservoir layer of the wicking bed. But when I looked at what was happening with the soil moisture, there was some interesting stuff. So this was the readings from the tensiometer that was sitting halfway down the soil. And so you can see that the soil moisture starts off, that's where the soil's pretty wet, almost what they call field capacity, which is where it's as wet as it can be with after all the free water's drained out. And then as time goes by, the soil starts to dry out. And then when I filled up the reservoirs again, the soil absorbed water and got wetter. Now the red line is the gravel. So after about 20 days, the soil in the bed for the gravel started to dry out quite dramatically, and it got far drier than any of the other reservoir treatments. The blue one is the one with cocopeat in the reservoir. The purple one's the one with sand in the reservoir and potting mix. And those dried out a bit, but not nearly as much as the gravel reservoir. The green one is the sand in the reservoir with cocopeat as the growing medium. And that dried out more than the one with the potting mix. But I'll explain what I think is going on there in a little while. I'll just leave you waiting for that. This brown line is the water ups, which you can see took a little bit longer to dry out than the gravel one did, but dried almost as much as the gravel. That was quite a surprise to me, but I did find out that was because the perlite wasn't wicking very well. And we'll see when we look at the next results that the water ups did much better when they had sand in as the wicking material. So this was from the second experiment, growing lettuce, and the brown line again is the water ups. And you can see that the soil moisture halfway down the depth of the growing medium with the water ups hardly changed at all. It stayed reasonably quite wet, very constantly wet. And the blue one is the cocopeat, where it was cocopeat all the way down to the bottom. That similarly stayed quite wet. The one with the sand was fairly similar to the first experiment, and the gravel one, the red one, that dried out more than the others, but didn't get nearly as dry as it did with the spinach. But the lettuce was not in there for as long. It was a much faster growing crop. Also, the weather wasn't nearly as hot when I was growing the lettuces as when I was growing the spinach. So it didn't dry out as much. This time, the purple line, this one, which was the sand in the reservoir with potting mix as the growing medium, that dried out as much as the gravel in this one. So it was quite a different result to what I got first time. And very soon we'll find out why. That's just putting the two graphs from the spinach trial and the lettuce trial just on the same slide, so you can see both of them. And there's a similar pattern, apart from the water ups, which there's an explanation for, and the potting mix one, which there will be an explanation for. The cocopeat and the sand and the gravel reservoirs behave pretty similarly in both experiments. So this is the explanation for the potting mix. This is looking at the soil moisture at 3 different levels. So the red one is 50 millimetres down from the surface. The green one's 100 millimetres down from the surface, and the blue one's 200 millimetres down. So that's almost So the growing medium was about 250 millimetres deep. So that's, the blue one's almost right down at the water reservoir, but not quite. So you can see that the surface of the wicking beds was quite a lot drier than further down. So there would have been evaporation happening from the surface. I didn't have any mulch on the surface in these. I just left the top of the growing medium exposed. So that sort of explains why the top is quite dry. The middle layer starts off quite wet and then dried out and then re-wet as after I filled up the reservoir. With the cocopeat, the bottom one, I only started measurements there because it was off the scale. It was right up, it was so wet right at the beginning. But you can see it dried out more than the middle layer did, but then it re-wet very well after I refilled the reservoir. On the one with the potting mix, the bottom layer stayed pretty wet pretty constantly. The top layer was very dry, and the middle layer got drier than it did with the cocopeat mix. So the potting mix was not wicking very well. The water was just going into the bottom of it, but then wasn't moving up through the profile to the roots above. So, I think potting mix is designed to drain when you have it, its normal use, you water from on top, and you don't want it to retain too much water so the water flows out the bottom. It's not designed to wick very well. So I think that something with finer material than you get in your average potting mix is a better growing medium. At least that's what it appears from the work I've done. The second lot, or the third lot of experiments I did was just some little wicking beds that I made in a bucket. To get them 500 millimetres deep, I used a bit of plastic damp coarse material to put an extension on top of the buckets, and they had a little filler pipe coming down and an overflow pipe just the same, but they were much smaller units. I could have more of them in a smaller area. And I just grew one plant in each of these wicking beds. What I wanted to look at with these was just whether geotextile had any effect on the wicking. So I could compare these results with the ones from the big wicking beds. So I did cocopeat mix with no geotextile all the way down, as I did in the other bed. I did cocopeat with a layer of geotextile in between. So there was cocopeat in the growing medium, geotextile, then cocopeat in the reservoir. And I did one with sand in the reservoir and cocopeat on top, but no geotextile. So that was different to what I'd done in the big wicking beds. And I did 3 of each of those. So again, I could see when there was any one bed was performing unusually. The results from that was there was no differences. So the geotextile didn't affect the movement of water through the beds. Now, there may be reasons to use geotextile to stop the soil mixing with whatever you've got in the reservoir layer, but it certainly doesn't have any adverse effect on the movement of water through the wicking beds. And that also showed me that these little wicking beds are a useful unit for experimenting in. I'm not sure you'd really want to grow a lot of crops in them because they're a bit small. But for doing experiments where you want a lot of replicates and try a lot of different variations, they'd be quite good for further research. So some of the conclusions I've got, things that I really found from this, was the capillary rise is greater in fine materials than coarse materials. So you get water will rise up better when the material's finer. And the movement of water from the reservoir to the into the soil was lowest with gravel, and it was best with the cocopeat or the water ups. The soil in the gravel, I showed you that graph where the soil moisture went way down with the gravel. There was still a lot of water in the reservoir. So looking at the the plastic tube up the side of the wicking bed, the water had dropped about 120 millimetres. So the reservoir was 200 millimetres deep. So the reservoir was still half full of water, but the water wasn't moving from there up through the gravel into the soil, which was what I thought would happen with those. But now I've shown that does happen. So if you really want to use gravel in a reservoir, it's not worth having it any more than about 100 millimetres deep. Or if it's deeper, you're going to have water at the bottom that never gets used, and you'll just have to refill more often than you might think you would. And based on the capillary rise experiments I did in the tubes, I wouldn't use Scoria at all. You know, I really don't think Scoria would work very well in the reservoir of a wicking bed. So the reservoir affected the spinach weights, but not the lettuce, as I said. So for a quick growing crop, it probably doesn't matter too much what you do. I think for longer term crops, tomatoes or perennial things, you would find that there was more difference between different reservoir materials, or you would have to water a lot more often with some reservoirs than some others. So the best soil moisture I got was with cocopeat in the reservoir, or the water ups with the sand. And the water ups with the sand wick better than just having sand on its own. Now, I'm presuming that is because in the water ups, there's a little bit of sand that's surrounded by free water. So the sand itself will, while it does wick water up through the sand into the soil, the sand also holds onto the water a bit. So by having less distance from the free water to go through sand to get up to the soil, I think more water is wicking up there. So I would suspect that a reservoir that's got lots of large voids full of water with just some wicks of sand would be good. So you could do that by having a big coil of ag pipe in the bottom of the wicking bed. So there was a lot of area in there where water could be. Or there's a couple of other beds which I built but haven't really done any formal experiments with yet. These ones I did with a sheet of core flute that I cut holes in and then put 100 millimetre diameter ag pipe in, filled that up with sand, and then put the cocopeat mix on top. The other one, I've tried one of my outdoor beds. I've just used 140 millimetre pots. They've got little holes in the bottom, filled those with sand so the water will come through the holes and wick up through the pots. And then I just covered the top of the pots with some mesh and then geotextile on top of that to stop all the soil falling down into the water. They seem to be working fine, but I haven't done any formal measurements on those yet. On the question of geotextile, I don't believe geotextile affects the wicking one way or the other. Interesting, I did find that the roots of the plants will grow through geotextile. When I disassembled some of the beds, there were lots of roots that had gone through, so the roots will go down and find water. Anyway, so geotextile isn't keeping roots out of the reservoir. Is geotextile needed? Maybe if you've got some coarse material like gravel in your reservoir, the geotextile would keep your soil out of it. But I suspect that the reservoir would actually wick better if the soil fell down and filled up the gaps between the gravel. That's my take on it. I've done beds for a long time where I've just done a coil of ag pipe in the bottom and put a mix of soil and compost all the way up, so the bottom of it's been totally saturated and then the top of it's drier, but there's no geotextile in between. The roots go down as far as they want. Now, I've not done formal measurements on those beds, but they're dead simple to make. There's not a lot of materials and they seem to work quite well. And I guess that's what I was emulating with the beds that I had that just had cocopeat all the way from the top down to the bottom. One of the things people wonder about, if you've got soil layer that's totally saturated in the reservoir layer, is it going to go anaerobic and become yucky? I haven't had that problem. Some of the beds that I've had that have had soil and compost in for probably 5 or 6 years, then I dug them up and the soil down the bottom was beautifully structured. It had nice pore spaces in, it had a reasonable number of roots had grown in it, and didn't seem to have suffered at all by being flooded a fair bit of the time in the reservoir. But again, I haven't done any formal measurements of a long-term experiment like that. So potty mix, I found it didn't work as well as the cocopeat, and I think that there's probably more work to be done on what's the best growing medium to use. And that's all for the future. Then one of the sidelights of what I did, the question is, how often do you need to water wicking beds? And I read things from, I only need to water them every couple of days to, I water them once a week. My general experience was I watered far less frequently than that. With the beds in this experiment, I put seedlings in and I watered them for the first 5 days only. So I think I watered them out 4 times in 5 days, and then I left them be. The spinach, I didn't need to add any more water for almost a month. And then another 20 days after that, I added water again. The lettuce, it was well over a month before I needed to do the first watering. And then I did a top-up watering because some of the beds needed it another 10 days later. The table there shows when the soil moisture dropped to below -20 kilopascals, which is a measure that's used in the hydroponics industry as that's saying pretty dry. They generally keep the medium well above -20 kilopascals of that's the pressure the plants need to exert to draw water out of the soil. But that's still pretty wet compared to the way the soil moisture that's in most garden beds. But the number of days that it took to drop down to that level in all cases was well over a month. So, I think the wicking beds from when you put the small plants in don't need to be watered very often at all. I did some measurements of, after I finished the lettuce experiment, I put tomatoes in the greenhouse and I watered those first time 39 days after I transplanted them, and then through the heat of summer with large vigorous tomato plants fairly crowded in those beds, it was an average of about once a week that I needed to water. So it wasn't that often, certainly a lot less water than you'd water normal raised beds with tomatoes in them. That's the end of what I've got to say. If you're interested in reading the full thesis that I've written, if you need something to send you to sleep, I've put it up on my website, which is roogulli.com, and Alex will send out an email in the next couple of days. It's got a link to that as well. So I'm happy to take any questions people have. I'll just sort of scroll through the...
So, Chris, did you want to, you can leave your screen share on or take it off?
You can take it off.
Yeah.
Yep.
All right. So I guess just one thing I did want to mention, Chris, was that Megan, Professor Megan Smith, the Executive Dean from the Faculty of Science and Health, was actually online. I just didn't see her. And she's from the Charles Sturt University. She just wanted to wish you all the best and congratulate you on the research, because I know that you haven't actually been able to have a graduation ceremony because of what's happened with COVID and everything like that. So congratulations. And I think that tonight's webinar is a really wonderful, thing that you've done, and it really sort of puts into focus all of that talk about wicking beds and actually what the science is telling us. So thank you.
Thank you.
And
thanks,
thank you for volunteering tonight and to sharing all of that wonderful information with everyone as well. So we will move on to the questions now. And so one is do you think we know everything about wicking beds, or do you still think there's more work to do?
I think I've really just scratched the surface of wicking beds, and there could probably be several more lifetimes of research. And I've mentioned some of the things that I think it still would be worth doing, particularly looking at the growing medium and what's the best growing medium to use in wicking beds. I think it will be interesting to work out how you know when to water wicking beds, given that with most of the wicking beds you can't actually see how much water's left in. Is there a soil moisture measurement that's the right one to do? Is there any advantage in letting them drying out occasionally? That sort of thing. There's a lot of questions I've got around that. And the other thing, which I think we touched on earlier with hydroponics, is I see wicking beds as, in some ways it's similar to hydroponics, but it's a lot less energy input than most hydroponic setups. And I'd like to be able to get nutrient cycling happening, so it's closer to organic growing. So you're putting in compost, you've got earthworms in there, you've got bacteria in there that are cycling the nutrients.
Yeah.
And can you operate a wicking bed in that way so that you're getting all that nutrient cycling? You're not having to put in too many external inputs other than compost. But can you get the same sort of production out as you do out of a commercial hydroponic setup? And I think that could be quite exciting for urban farms, particularly in the future, if we could really nail that one.
Yeah. So I think that where we were up to, Chris, was Peter asked, what is the brand of moisture meter from New Zealand that you use?
It's called Pulse, P-U-L-S-E.
Okay.
I can give Alex a link to when she sends out the email.
Okay. And Jan asked, great, thanks, Chris. Jan asked, I don't know whether you've got any experience with wicking beds and ring culture. Have you had any experience with that at all, Chris?
No, I don't know what ring culture is.
All right, so we might leave that one. There was a few comments about the medium you used, Chris, cocopeat. Just tell us what that is and where you sourced it and that sort of thing. There was a comment that, just tell us what it is.
So it is the outer husk of the coconut. So it's a byproduct of the coconut industry. Uses the waste product from there. Most of it, all of it, I think, is imported. A lot comes from Sri Lanka, I think, but it comes in compressed blocks. So that it's pretty efficient to transport, and then you put it in water and soak it, and it really swells up to 6 or 7 times the size of the block. It's used quite a bit as an alternative to peat moss, which is a bit environmentally unfriendly as harvesting the peat moss. Okay.
So for there's a question here about young plants. I think you've sort of answered that in your presentation, but do you recommend watering from the top to help the roots establish, or did you just do that saturation watering at the start? And then I noticed you said you'd left some for 39 days. So you didn't do any other watering?
I did water them for 5 days, or I think 4 times over 5 days at the start, with about a cupful of water per plant. So it wasn't a huge amount of water, but I think
Yeah.
I did notice the spinach plants, seedlings I put in were really tiny and quite weak, and they did start to wilt a little bit, so I did need to water those. Yeah, but I've read some people saying water them for the first 2 or 3 weeks. I certainly found that, certainly inside the polytunnel, 5 days was plenty to, adding about a litre of water over those 5 days was per plant was plenty. If they were outdoors in the wind, maybe they'd need a bit more, but I think the roots get down pretty quickly.
Okay. So the next one is, have you tried, this isn't really related to wicking beds, but have you tried koi mixed in with a vegetable garden mix? Would that have been pretty similar to what you used, or?
Yeah, I think so. I know it's. I have read about people that are using it to add organic material to conditioned soils, and it doesn't tend to break down too quickly. So it provides quite a lot of structure for quite a while. So I think it's a useful product in that way as well.
Okay.
It's also used in aquaponic setups as the growing medium, just cocopeat coir on its own, that they then add nutrient-filled water to.
Okay. So, given that water ups have an air gap that lets sodden water drip back into the reservoir, would we expect less wicking height and rate from them?
I don't think so. I mean, any reservoir, a gravel reservoir is going to have an air gap, have in the spaces between the gravel once the water starts dropping. I think the wicking up through the sand legs of the water ups will happen just the same whether the reservoir is almost completely full or almost completely empty, and the draining of water back into it wouldn't affect things at all. I read of one paper where someone described a system that was really like a wicking bed without any medium in the reservoir. They just had plants growing in a little basket that was suspended above a tub of containing water with nutrients in it, and the plants used the water, and the water level dropped and the roots kept growing down, so they stayed in the water. And that was, so there was an air gap between the water and the plant that had roots going through it, and they grew quite happily. So I'm not sure air gaps are a big issue. Okay.
So there's a question here from Ricky, just about, did the potting mix have compost added or just the cocopeat mix?
Yeah.
So do you think that could have influenced the way that it performed?
Yeah. So the cocopeat, the compost was just plain compost as it came out of the bag, and the cocopeat mix had cocopeat compost and sand. But the potting mix had a fair amount of fertiliser in it, and then I added a bit of fertiliser to the cocopeat mix as well. So, I think that there was enough nutrient in both growing mediums that wasn't going to affect how the plants grew.
Yeah.
But adding compost, which was quite a fine compost, it was really well sieved, so it was all just small particles.
Okay.
I think if you added 20% maybe compost into that potting mix, that would have filled up all the little gaps in there, and it probably would have worked better.
Okay, so there's some questions here about the medium. What would you suggest is the best medium to use in wicking beds, in terms of the growing medium? What would you suggest?
Yeah. I've had good results just getting soil from the garden and compost and mixing that sort of 50-50. The cocopeat compost and sand mix worked very well, but it's probably not a very cheap thing to do if you're doing a lot. I've had very mixed results. I haven't done a lot of formal experiments, but I did a couple early on with some soil mixes from a soil yard, and there was a veggie mix and a premium soil mix and something else. But there was a lot of variation in the particle size in them. Some of them had composted bark that wasn't very composted in, and they didn't tend to wick very well. So I think you can try a fairly simple experiment if you can get a tube or make a tube out of acetate or thick plastic. If you can wrap it into a tube, put rubber bands around it, fill it up with whatever soil you think you might use, sit that in a container of water and just see whether the water comes up through it okay. Before spending a lot of money on getting soil from a soil yard, that would be a fairly simple experiment to do with just a little bucket of soil.
Yeah.
But you need to have something that hasn't got a lot of air gaps in it, that's got quite a few fine particles in there.
Right. So I'm just going down to, you touched on the condition of the water in the reservoir, and did it tend to go off or anaerobic? And was there any concern? Do you need to flush out or clean the reservoir between plantings?
I haven't found that to be a problem. I mean, this was growing 2 crops over about 5 months, so it wasn't really a very long-term experiment. But I've never had any problem with wicking beds starting to smell or anything apparently nasty happening in the water that's affected the growing. So that hasn't been my experience, but that's not to say in longer term that it wouldn't. I can't say that definitely it wouldn't be necessary to drain it all out, but I don't think so.
Yeah. So there's a question there about if you're setting up in a place where you can't water often, could you have a taller refill pipe on your wicking bed?
No matter how tall the refill pipe is, once the water level in that pipe goes above the overflow level of your overflow, it's going to come out.
It's going to come out anyway.
So it really would just is have a bigger reservoir if you can water that. So and I found the sand in the Perspex tubes, water would happily wick up the sand at least 30 centimetres fairly quickly.
Yeah.
So, I think if you had a reservoir that was something like the water ups or those other ones I showed you that I was doing with the pots, you could have a deeper reservoir. You could have a 30 centimetre deep reservoir with sand wicks in there, and then you could put a lot more water in that than you could put in a shallower reservoir. So
with those ones that you use the pots with, and I saw the pots with the sand in them, and then you had a bit of white mesh over the top.
Yeah.
Did you use geotextile fabric on the top of those to stop the reservoir from being contaminated?
Well, it was because there's all these gaps between the with sand. Yeah, so I did put geotextile on that to stop the soil falling down in there. So
and was it effective at doing that?
I haven't dug it up to see, but I don't see why it wouldn't have been effective. I think it would be fine.
Yeah. Okay, so let's keep going. Do you fertilise the water in the reservoir or in the growing medium?
So I was just relying on the fertiliser that was in the growing medium. I've never tried putting fertiliser in the water. I think it would probably work okay. What the long-term effects of that would be, I don't know. One of the questions that I did ask early on that I did look at was whether having this water that was constantly moving up through the growing medium, and then some of it evaporating from the surface, where that would lead to a build-up of salt on the surface of the growing medium. Because one of the things that happens in commercial horticulture sometimes is that when you're doing a lot of irrigation, you get build-up of salts on the surface, and sometimes they do a whole lot of over-irrigation to actually flush all those salts out and wash them out the bottom of the soil. But I did measure the electrical conductivity, which is a measure of the level of salts in the medium, and I didn't, over the 5 months that I was growing things and measuring it, I didn't see any increase in salt on the surface. But I wonder if you had these salts, the fertilizers dissolved in the water, if that may become more of a problem in the long term. It would certainly be something to watch out for.
Okay. So there's just a question here from Tiffany about, do you postulate a prime size for a wicking bed container? So, for example, could you have a half 4,000 litre rainwater tank cut in half? Would that be an effective container? Or you're not too sure?
I tell you, I've never used anything bigger than a bath or the IBC, which probably both about 1 square metre. I don't see any reason why a bigger one wouldn't work. You need to think about what depth you want, because certainly for growing annual veggies, having a total 500 millimetres deep with some 200 millimetres reservoir and 300 millimetres for the growing medium seems to work well. If you have deeper than that, it's probably deeper than necessary for annual veggies, but for perennial plants, maybe more advantage. And it's more expensive if you're going to fill up a bigger one. So, but certainly as far as diameter goes, I think it's not going to matter. As big as you like.
So there's just a question around the Scoria and why did you think it didn't work? Is it due to the size of the material, or was it something to do with the actual material itself?
I think it's mostly the size of the material, that the gaps between the Scoria particles are just too big for capillary rise to happen in there. So in that way, it's similar to the crushed gravel, but the crushed gravel did wick better than the Scoria. And what I think happens is that where the water's going up the gravel, it's actually just going up by adhesion to the surface of the gravel particles. It's not actually dragging other water molecules up with it in the spaces between the gravel particles because they're too big.
Yeah.
Scoria, which has got a really rough pitted surface, there's not as clear a path for the water to go up adhering to the surface of the Scoria so that it doesn't go up very far at all. So, I think it's a combination of those two things that mean the Scoria wasn't wicking very well at all.
Okay, so we've just got a couple of questions here about, there's one about where we would source bulk amounts of cocopeat.
Yeah. Have a look at suppliers to the commercial horticulture, commercial hydroponic industry.
Yeah.
I bought it in blocks that were, I can't remember the volume. They're sort of about 30 centimetres square and 20 centimetres deep. And the commercial operations buy those by the pallet load. And so I'd be looking there. If you're going to buy it from Hammer Barn, one of the hardware shops or garden centres, it's cost you a fortune. But I think if you're buying a large quantity, you should be able to get it through some wholesaler.
So have you looked at the commercial wicking bed mix from BioGrow?
No, I haven't. Would be interesting to try that. Yeah.
Oh, there was a question about whether you get salt build up from the cocopeat, but you just explained that wasn't really a problem.
Yeah, because the cocopeat it's often apparently washed in salt water and is part of the processing in Sri Lanka or wherever it comes from. And I've read of concerns about it being too salty, but I've never, the stuff I've used so far, I've never had any problems with that. So, certainly if you're buying a lot of cocopeat, it would be worth asking a question. But, I think cocopeat that's being sold to commercial horticulture industry is probably going to not have that problem.
Yeah. So there's a pretty good question here from Jenny and John, I think, that says some wicking bed setups recommend a water retentive layer above the reservoir when and between the reservoir and your planting medium of approximately 30 centimetres. Would you recommend using cocopeat, or is it even necessary?
I haven't tried it, but I can't see why it would really be necessary. I think that the whatever growing medium you use should be able to wick water and hold enough water for the plants to grow. And the roots are going to go down. Once you've got enough water on top to get the plant started, the roots are going to go down to where the water is.
Okay. So there's a question there for the beds with the sand wicks. Do you need a soil barrier between the water reservoir and the growing medium? Or was there already a plastic reservoir there, plastic barrier?
With the water ups there is, so there's the plastic unit there.
Yeah.
With the ones I made, I had one of them. I had plastic core flute, just that little stuff they use for signs, like corrugated cardboard, only plastic. But that was just as a, all it's got to do is support the growing medium that's above it. And the ones I did outside with the pots, I just had the Geotextile providing that support. I don't think there's anything magic about having a particularly solid layer there, as long as it's enough to stop the soil falling down into the water.
Yeah. So Kathy just asked, I'm just going to reassure Kathy that the webinar is being recorded, and we will have a summary and a link to this webinar on our website when we publish the summary, and that will be, I'll send that out, notification of that. I will actually send it out to the people who've registered for this webinar. And I will also put it into our newsletter that you can sign up for on our website.
Yeah.
We've had another question there about Scoria. I think we've sort of answered that.
Yeah, I'll just say it's puzzled me a bit about Scoria and gravel, that it's used so much, and there are so many people that are happy with the way the wicking beds work with Scoria and gravel, that there's something going on there that means they do work, at least to some extent. And I've got a few theories that, it would be another project would be interesting to explore, to really interview people about how they actually operate their wicking beds. I suspect sometimes there may be watering more often than would be otherwise necessary if the reservoir was wicking better. Maybe it's getting more water from on top than you would think would otherwise be necessary, certainly if they're out in the rain. And there's one curious thing it's a little bit counterintuitive, but if you've got a layer of soil and a layer of gravel underneath it, so the soil's got small pores in it and the gravel's got big pores, if the soil is saturated until it gets really, really oversaturated, water tends not to move from small pores into big pores. So if you get a whole lot of rain that comes on your wicking bed, it's going to saturate the soil, but not drain. A lot of it won't drain out into the gravel. So if there's, rain once a week or even once every couple of weeks, you're probably getting that layer of soil wet enough for things to grow, and it doesn't matter what happens down in the reservoir layer.
Okay.
That's a bit of speculation, but that's
yeah,
based on the physics of how water moves in between particles. It seems logical to me.
Well, that's interesting. Yeah. So there's just a question here from Mary about what your thoughts are on using dam water in wicking beds. She's used it for a while and saw white scum coming out of the drain tube. She wondered if it might be toxic to the soil with too much bacteria from duck manure in the dam or something like that.
It's not a problem. I've had all my wicking beds for the last 13 years have been watered with dam water from the dam on our farm, which certainly has a lot of ducks in it, and other critters. So yeah, so dam water per se is not a problem, but there's obviously something growing in those reservoirs that's causing that. But I don't know what that would be.
Okay. So we've actually got about 50 messages there. I think we've really pretty much covered everything. There's one question there about, have you ever thought of using concrete premix being blue metal river sand and a fine sand and having a drainage sock around the ag pipe? Do you think that sounds like it's a fairly fine mix?
Yeah, that would probably work okay. Just based on my capillary rise experiments, the crusher dust would probably be the best thing to use for wicking. I've read some people speculating that would affect the pH of the soil, that the crusher dust is quite alkaline. And that's what's in a lot of these concrete mixes as well. I just don't know about that. It's something I'd like to try. When I do use coils of ag pipe in the reservoir, I often do have the geotextile sock around it to stop them filling up with sand or soil.
Right. Okay.
I think that is necessary.
Yeah. So there's just a question here about, have you tried like a really high, I guess lettuce is fairly high water use, but have you tried zucchinis? And if so, do you need to water them more frequently? Perhaps you haven't tried zucchinis.
Yeah, I haven't tried zucchinis. I've grown rhubarb in wicking beds, which grows quite happily. But yeah, I think as you get a lot more leaf area and bigger leaves, you get a lot more transpiration. So you're going to have to add water more frequently. But yeah, so tomatoes, it was watering once a week. The spinach and lettuce was watering once a month. So yeah, so the watering frequency does depend on what you're growing.
Yeah, and there's a question about, do you suggest to use water ups or ag pipe with growing medium straight on top without geotextile? I think you were more or less suggesting that, weren't you?
Sorry, water ups or?
Yeah, sorry. Are you suggesting the use of water ups or ag pipe with growing medium straight on top without geotextile?
I think either of those works. The water ups are dead simple to use, and particularly if you're constructing a wicking bed that's to the same dimensions as the water ups things, or you can use them as a in whole units. I had to cut them down to make them fit in the IBC, but they seem to work well, and they're very simple and straightforward. But then they do cost a bit to buy, and may be able to do something cheaper with ag pipe. But I think either of them will probably work just as well.
Okay.
And if you've got ag pipe, lots of ag pipe with a geotextile sock around it, and you say filled up with sand just to the top of the ag pipe, so you don't have to have a lot of sand above it. I just put the growing medium straight on top with no more geotextile.
Yeah, okay. So there was one person who just made the comment that they are doing some research as well, and would like to to have a chat. So yep. Chris, if that person could send me their details, I can definitely put you in touch.
Certainly, I'd be happy to do that.
Yeah, great. All right, Chris. Well, I'll just finish off with a few messages from the Small Farms Network and then we'll come back and wrap it up. Okay?
Yep.
Okay. All right. So I just wanted to let you know about the Small Farms Network and how you can become a member. You can do that on our website. And you can also find some resources or sign up for our free newsletter on our website. If you like what we do, we encourage you to become a member so we can keep doing events like this one. Members receive a lot of benefits, including early alerts for upcoming workshops, discounts for some events, opportunities to participate in special interest groups and members-only events. And you can also submit notices relevant to small farms that can be advertised in our newsletter. So currently our members-only groups, we've got a sheep husbandry group, and we also have a small business group, and they're currently meeting by Zoom, and when COVID allows, we're hoping that we'll have some special events in person as well. We'd love to get your feedback about this session today. So when the Zoom session ends, you'll be directed to a survey link, and it'd be great if you could fill that out for us. You can leave a comment in the chat box, and you can also email me on the admin address. The Small Farms Network has a discussion group on Facebook, and we are inviting you to join that discussion group if you'd like to talk about all things small farms. And that's where you can post your ideas and comments, and also any pictures that you wanted to share from your property. And you can also like us on the main Small Farms Network Capital Region Facebook page. We also have recorded all of our webinars, and we've done some other little special clips about small farms on our YouTube channel. So we've got everything ranging from chickens, backyard chickens, right through to acid soils and sheep. And that's a good place to catch up if you've missed any of our previous webinars. So, yep, that's our details there with the Small Farms Network Capital Region on our website and Facebook. And we'd love to see you join us. All right, Chris, fantastic. That was a wonderful webinar. Thank you so much for your time.
And thank you, everyone, for all the interest in it. It's very gratifying to see that people want to learn about this. Yeah, and if there is any questions that haven't been fully answered, we'll try and get those questions out to you, those answers out to you. You can always email me if there's anything we missed today, and we'll try and get those questions out to everyone. So thank you very much, Chris. Yes. Bye.
Bye, everyone. Bye.